You just heard in Swara's presentation an overview of everything that ETC does, and it's now my job to actually talk you through some of that and attempt a live demo. So we've just got a couple of slides here, and I should say thank you to Swara because she actually prepared a lot of this demo as well. It's just a couple of slides to give a little overview of the kinds of things I'm going to look at. So just going to create scenes and sources just to set up calculations. I'm going to show how you can copy and modify workflows, upload user-supplied spectrum, and then use that in a calculation, so how to do that properly. Demonstrate the batch expansions function, which is a very useful feature of the ETC, and also how you can share workbooks. So I hope that along the way, I'll be able to kind of demonstrate how you go about setting up your calculations, some of the useful features, and probably also some warnings and errors along the way. I have two individual demos. So in the first one, these are some of the features I'm going to show. So these are very much some of the really basic functionality and how you start off with your workbook. I've put at the bottom there also the link to JDocs. I won't be able to talk about every little aspect in detail, but the JDocs pages for the ETC do detail a lot of what goes behind the setup and the different functionalities. Okay, so I'm going to quit this presentation and launch the ETC. Oh, God. Okay, that looks good. So on this front page, when you go to the URL, you have some information, some updates. So for example, this is a nice one. You can see if there's downtime, it will be announced on this landing page. And here there is a README file with a few, some caveats. All right. In WebEx?
Yes.
Okay. Share screen?
Yes.
All right. So these initial notes are worth taking a look at. I'm going to log in here with my MyST account. And that gives me access to my whole list of all my workbooks that I work on. Make sure I remember my password. Okay. No. So here's the, my own kind of listing of workbooks. Can give them all, names and some descriptions to help you. So for this demo, I'm going to create a new workbook to start off with. I have this new workbook here. I'll load it. So here you can see the kind of interface when you go into the ETC and you create a new workbook. Swara already showed some screenshots of this. This is nice and blank. So first of all, before you can do a calculation, you have to actually create your source. So you go here to the Scenes and Sources tab. And what you have here is two lists here. So this is where you have scenes, and scenes are basically sort of little postage stamps that will contain your source. And any given scene can contain one or multiple sources as you want to define them. There are some defaults here when you first log in. So here is the listing of sources. And so before you've created anything, there will be a default source here. And what's nice about the ETC is that it does have these default things loaded in when you first start create a workbook. And these will sort of give you some sensible information. So to start off with and show some of the basic things, I'm going to just work with this default source here. Here in this source editor, this is where you basically define everything about your source. There's a number of different options here in these different tabs. You've got an ID tab, so you can actually give your source a name, which will then update here, so you can see it. In the bottom half here, you have some plot windows and some further information. By default, this source, this star, is already part of this first scene. So once you start creating more sources, you actually have to kind of allocate them to a scene. But here in the default, because we have just one source, that is part of the scene. So if you select them, you can see here, this is your scene with the source in it. This is currently the source spectrum, because right now, if we look at here in the continuum, you have a number of options in this drop-down list. And so right now, this is selected as a flat continuum. So this is basically, a flat continuum. In the Renorm tab, this is where you would define basically the normalization. You have a number of options there. So you can set a flux magnitudes in various units at different wavelengths, or you can normalize in actual band passes, so either for one of the James Webb filters, HST, kind of Bessel, Johnson, SDSS, Spitzer band passes, or you can choose not to renormalize. Okay, so we have this very simple basic source with a flat spectrum. Let's create a very simple calculation. And I'm going to do a NIRCam image. Oh. Okay, so this is, if you change anything, you always have to make sure you save first before you make any changes, because otherwise you may lose them. The ETC will prompt you, so I'm going to say save. So I now have a default calculation of NIRSpec short wavelength imaging. And you can immediately see this has actually created, this is giving me this little exclamation point, which means there's something to look out for. I have this warning here telling me that there is saturation. Well, that wasn't in my notes, so I'm going to go back to my source. And okay, because I've changed what the normalization was. That was the change I did. That wasn't supposed to do that. So I'm going to go back to this. This is the default value, so it's 1 microjansky at 2 microns. I'm going to resave that. And what you see then, because I've changed something to the source, this calculation has automatically updated. And so now it's not giving me any errors. I have a green tick mark there, which means the calculation was completed without any problems, and I have a signal to noise here of 96. So if we look at the panels here in the bottom, you have here the 2D signal to noise ratio map. So this basically shows you a little mock image of that star. You can look at the detector, and this is the saturation map. So it shows that there is no saturation, which is great.
When did you provide the explosion side?
Oh, yeah. Oh, sorry. I'll go through these different options. This is the kind of the default when you create a calculation. It does put in some sensible defaults. But I'll go through all the different options now to show how you then set it up to the exposure settings that you want. So Swara already mentioned the background, so you have a tab here to set backgrounds. You can provide here the RA and DEC of your target, which you strongly advise to do for an accurate estimation of the background. Seeing as this is not actually a real source, I am just going to leave this blank for now. Okay. And so you can provide more detail about sort of low, medium, or high-level background for that location, and you can set a date as well. You have the Instrument Setup tab where you have where you can choose for that particular mode. So I've got NIRCam shortwave imaging here. You can select the filter. I'm going to leave this one for now. The Detector Setup tab. So this is really where you set the exposure time. So again, it will have in subarrays and read patterns all the various options in these lists for these calculation, for that particular type of calculation. Read patterns. And then you have groups, integrations, and exposures. In strategy, it then defines how gives more information about how the signal to noise will be calculated. So you can specify here where your aperture will be. We just have a star in this particular target, so I can say we're going to be centered on this source. You set here the aperture radius, so this is for the circular area that the flux will be extracted from. And you define the sky annulus. Again, Swara showed these plots. This is how you would perform photometry. Once you've set that up with all the correct parameters for your observation, then you hit calculate. So for this workbook, like I said, I just picked the default source and created a default calculation, and that does actually come populated with reasonably sensible numbers, so that that can get you started very well. You can copy calculations. So if you want to, you don't have to start from scratch. So if you just want to copy and just try something different, so for example, you just change the filter. I change to F150. And you hit calculate, and then it will do the same calculation for another filter. From here as well, so this actually shows you a summary of your source. So I can here then also make a change. I want to, it's actually 4 microjanskis, not 1 microjansky. And you hit calculate. And then you see both of these will update because both of these calculations use that same source. You can also use the copy function for sources. So I'm going back to the scenes and sources. I can do copy source. And then it will create me a new target. Let's call that star 2. Now, this here in scenes is actually blank because I've created a new source, but it's not going to automatically assign that to a scene. So if I then also create a new scene, scene number 2, as you see, this here under sources is blank, so this scene currently doesn't contain any sources. So what I'm going to do is I've got star 2 selected, and then I do add source, and that now associates that source to scene number 2. So that's how you can combine scenes and sources, and you can create a whole list of them. Okay, I am going to go back and create actually, no, let's just do this in the same workbook. I'm now going to, for this second star here, what I'll show is how to then associate that with your own spectrum. Say you have already observed something with Spitzer, and you would like to know how that's going to, how you want to set up observations with James Webb of that target. So then you can go to the Upload Spectra tab here, and then here in the bottom you can select your file. Bruno, where does this download?
Okay.
No, no, because you literally just download. Downloads. Can I just search for it? If you just go to search. Yeah, that's it. All right, so I have a spectrum, a Spitzer spectrum of a star, HD 33133, which is a Wolf-Rayet star in the Large Magellanic Cloud. So this is very simple. So the documentation gives you an overview of the requirements for custom upload spectra. You basically have the choice of an ASCII file, but then you really have to have the right units in the file. If you use a FITS table, you have a little bit more flexibility with what units you provide because you can put them into the header. Okay, so I have now uploaded the spectrum. You can see it here. You can add some notes if you like. I go back to my scenes and sources now, and now I want to basically assign that spectrum to this star number 2. So now if I go to specifying the continuum, you can see here in this drop-down list I have an option. So I want to select this one. You can upload a whole range of your own spectra, and then so you just select the right one from this drop-down list. Because this was already uploaded this was a flux-calibrated spectrum, I no longer need to normalize, so you then select Do Not Renormalize, so it literally just reads in the spectrum as the numbers are given. And then if I look in the plot window, you can see this is a spectrum. So,
what is the structure of the file?
Sorry?
The structure of the file?
Yeah, so what I uploaded is a simple ASCII table, so it's wavelength flux density in Milajanskis. Like I said, if you can also upload a FITS table, and then you have a little more, there are different units you can choose. So there is a very good page in JDocs that tells you exactly what the requirements are for your uploading your own custom spectrum. So I have here, this is a spectrum of about 5 to 15 microns. I can show here as well, you can actually adjust the axes here. You can hit apply, and then you can see a little better. Now I want to perform a calculation with my second source. I'm going to do mirror imaging, so we can't use this for near infrared because the spectrum only goes to down to 5 microns. So I select the calculation, and then you have to make sure here that we also select our new star. So this was scene number 2. I select scene number 2, and then also star number 2 will come up here. And you can, for a sanity check, you can see what you had how you had defined this source. For the backgrounds, I'm going to put in the coordinates of the target. This is a mirror imaging calculation, and I would like to do imaging at 10 microns. Again, here you have all different options. I'm actually going to choose a subarray here. And let's see what we get if we put in 20 groups for a single exposure. I'm going to hit calculate. Okay, it looks like the calculation completed without any errors. Now, say I really have no idea how many groups I need for this calculation. Swara mentioned we have this batch expand feature that lets you kind of explore parameter space. Now, this particular target, it's pretty bright. You're probably happy with signal to noise of 300. But just to demonstrate this feature, you have here in the top menu expand. So with this calculation selected, I'm going to go to expand and go to expand groups. So let's say I'm going to start with 20 groups, but I want to see how the signal to noise is going to evolve over time. So I'm going to do 5 iterations, going up by 5 groups each time. Then when you hit submit, it then creates 5 copies of that calculation, each incremented with the step size that you have defined. Other than that, all the settings are exactly the same. So this is the exact same calculation, just incrementing the number of groups. So what's then neat is that you can then select. So these checkboxes are for plotting. So you can compare your calculation to all the others. And then here it will plot all these individual data points in the window. So this shows you then the signal to noise ratio as a function of time. So that can be a really useful feature if you're trying to figure out kind of how the signal to noise will evolve and what the right kind of number of groups might be for your observation. You can do similar expansion with integrations as well. Yeah.
Stupid question. What is groups?
Right. So basically, a group is a single read up the ramp. So does that make sense?
We have provided a flyer Astronomy Table flyer with the definition of group.
Okay.
Disclosure without terminology.
I like to think of a group as the thing you download to the ground. You may read a frame, or you may read 4 frames and combine them. The group is the thing that actually
Right.
comes to the ground.
Ah, okay.
Yes. So yeah. Eric?
Yeah, more generally speaking, is there somewhere a document where you can find the exact definitions of all the words and terminologies that are used in the ETC?
Well, I mean, the terminology we use in the ETC is consistent with the terminology we use for the instrument and the observatory in general. And that is all defined in the documentation. We have dedicated pages explaining in a lot of detail how the detectors are read out, what a frame is, a group, an integration, and an exposure. So that is detailed, yes.
So you basically have to read the documentation before being able to use ETC, right?
No, that is a false statement. You would never get to that point and you would not have a cycle 1. I sense a little bitterness coming from you here.
No, because I thought this a few times ago.
You did what, sorry?
I tried to use the ETC about 6 months ago.
6 months ago?
Yeah, and I was really, I didn't know how to interpret some parameters. These parameters were brand new, and I didn't know how to, what was the exact definition, and I really struggled to find the definition.
Yeah, I appreciate that. We have gone through a lot of work since then to harmonize the terminology between ETC and APT and to make the labels match better. And we've written a tremendous amount of documentation now. If you have a specific question like what is a group, you should be able to find that in the documentation using the techniques that we went through yesterday.
It would be very nice to have a glossary somewhere. You can click on group and you get an exact definition.
Understand? Thank you. We'll look into that.
Yeah, we have also discussed how to better link the ETC straight to JDoc so you can get to the right page. So, yeah.
So if you do a 4-point dither pattern,
Yeah.
would that be 4 groups, or would the telescope actually combine the 4-point dither pattern and you get it as 1 group?
That's a good question. So you have n groups that form an integration. So we do non-destructive reads. So you can read n group times before, in an integration. The end of the integration, that's when the detector gets reset between integrations. Okay, so you get these sorts of ramps. You have n integrations in an exposure. So that's where you set the parameter here. can tweak the number of integrations in an exposure. If you want to implement a 4-point dither pattern, that would be 4 exposures. So if you have this exposure set, the exposure number set at 1, that assumes that you will be at that position for that length of time. So the time is also reported here.
So if you're doing cosmic ray splits as well, it would be 2 integrations with 4 exposures then?
Yes.
But you will not need to do cosmic ray split because again, you want to start without. So if you constantly cosmic ray doing your integration, you will be able to figure out through the pipeline. You will need to start a CCD that you will know when cosmic ray is better. If you have to run without, you will see your ramp when the cosmic ray and you can still get the flash rate.
Yes, may I suggest perhaps for the benefit of the crowd to go to the JWST and show what is the integration and exposure and such?
It's also yeah, just put it out put near camping on the search.
No camera. Okay, so this is the documentation page for NIRCam detector readout. There we go. Right. Is this big enough for everyone to see? Think we can make it bigger? There we go. Okay, so this shows a schematic of how, what an exposure consists of, right? So this is your full exposure. You can have this particular exposure has 2 integrations. You see it has a reset here, so it has 2 up the ramp sets of reads. These green points are individual frames, and in this setup, 4 frames are averaged into a group. And so your exposure, you start by defining the number of groups you want. And so in each group, you have 4 frames that get averaged. And that sets your exposure. Does that make sense? Should mention for MIRI, we don't average frames per group. So for MIRI, there is 1 frame per group.
And the duration of each of the green points is prefixed?
Yes, yes.
Okay.
But yeah, so if there. Again, those values are all listed in the documentation, but also the ETC calculates that for you. Obviously, a lot of the instruments have different subarrays, which may have which have shorter read times than the full array. But the single group read time for one particular array for an instrument is a fixed number.
So the science time, the object, the time on target is prefixed as well. I mean, coming from a more classical optical spectroscopy, you say, I want to spend 30 seconds on this target. My question is, those 30 seconds are fixed in NIRCam, for instance?
Well, I mean, you can specify, depending on the brightness of your target, you may want to do that integration time in one integration. So you want to just have this in a single ramp, or if your target will saturate in less than that time, you might want to break it up into multiple integrations so that you reset before you saturate.
Yeah, my question is that the duration of each of those green points is always the same. I just need to find out how many green points I need.
Yes,
Okay.
yes, that's right. Yep. Yep, yep.
But can you explain the difference again between the integrations and exposure?
Okay, so to repeat the question is to explain the difference. Sorry, what was it?
So what's the difference between integration and exposure? Because from what I see now, there's no difference, right?
So the question is whether I can explain the difference between integration and exposure. What do you mean there's no difference?
Like, because you reset the detector after one integration, and you keep on doing that,
Mm-hmm.
and suddenly you decide X number to be an exposure,
Correct.
and there's no is there a reason to do that?
Well, for example, if you want a dithed exposure, then you want X amount of on-source time, but within that time, ideally, you should do 4 dither pointings to get good sampling. So then you might want to break that up into 4 exposures, so that you can do those dither pointings. For other things, like if you want to do a transit spectroscopy for 10 hours, you might want to do that in a single exposure. Strictly speaking, there is a limit of 10,000 seconds to the length of a single exposure. For things like very lengthy transit, transit spectroscopy or time series observations, you can go longer, but you're expected to justify that.
One last question.
So basically, to set up the number of integrations, you would want to set that based on saturation. So if you're not going to be saturated, you could just do one integration. But if you're going to get saturated,
That's correct.
Okay.
Yeah, that's
Thank you.
correct. Yeah, if you're not going to saturate, you might as well. I mean, the general rule of thumb is the more samples you have in this integration, the more data points you have to fit a ramp to, so the better you expect your calibration to be. But of course, you don't want to saturate.
Thank you.
That's it? Yeah.
Thanks.
Okay, so I think we should thank Sarah for the demo.